Um, Someone talk to me about what increasing and decreasing is in your terms. Yes. Okay. So you could increase or decrease the value if you're looking at values. Okay. Tell me what it means in terms of graphs. Increasing by 1, increasing by 2, you can increase at a steady rate, right? What would that look like on a graph? Okay, so like with your pencil, if it was increasing like this, like slanted up. Okay, so if we did something like, nope, something like this, if this is my x and this is my y, and I were to increase like this, that would be an increasing graph. Do y'all agree? Is that increasing? So then what would decreasing look like? Show me with your arm. What would decreasing look like?
This or that. Wait, what?
Okay, we read graphs from left to right, correct? So it'd be this way, right? Or this, right? It could be steep or not steep. Okay, so here's my x, here's my y. So you're saying decreasing would be something like this? Okay, so now let's put that into words. Because I agree with these. These are perfect. These are perfect representations of what increasing could be. Now, are these the only options for increasing and decreasing? No, of course not, right? It could be any rate of change. There could be all kinds of things, right, that it could look like. And you'll learn next year in algebra that some of the graphs increase and decrease at the same time. But I'm not going to get into that. So, tell me, let's put into words what increasing and decreasing is, what it means. Okay? So, yes, sir.
Does it have to relate to graphs though?
Yes, I want it to relate to graphs. We're going to talk about in real life what it looks like, but as of right now, for this definition, I want to look at increasing and decreasing with graphs. Okay, so we read graphs how? From left to right. And what part do we look at first? The x values always. Okay, so we're going to start here. Okay, let's say we're starting here. We're going to read left to right. Okay, so what can you tell me about the x values for reading from left to right in this graph? They go up, right? They increase, right? They go up in value, 1 by 1, 5 by 5, however it's increasing, right? It's increasing the values of the x-axis, right? What is this line doing? What is it connecting? The dots. Okay, so let's imagine there's some dots here. All right? So let's say that this is 1, 2, 3, 4, 5, and 6. Sure?
Yes.
Okay, so from here to here, the x values are increasing, correct? Okay, so the first part of our increasing definition says, as x increases. Comma, huh? Is this a function? Yes, it is a function. Very good. So as x increases, the next part of our definition is going to be the other part of the graph, which is the what? The y values, the outputs, right? What are the y values doing? 1, 2, 3, 4, 5. So this dot right here, 1, 1. The next dot I go to on the line is 2, 2. So what are the y values doing each time? And increasing or decreasing? Increasing, right? The y values are also going up. So as the x values increase, the y values increase. Well, then would it be an increasing line if it was just horizontal? That's a really good question. Y'all see what she's saying? She says, well, what if it looks like this? Is that line increasing or decreasing? No, what is it doing? Nothing. It's just constant, right? Very good question. All right. Does this make sense? Y'all with me? Okay. Do you think it would help to draw the picture? Then draw the picture. All right. so we're going to look at the x-axis. We're going to start right here, and we're going to move which way? Left to right, just like when we read a book, right? Left to right. So we're going to go this way. What are the x values doing? Nope. What are the x values doing? Increasing, right? We read from left to right. You with me? From 0 to whatever number this could be. That's increasing. So as the x values increase, what are we going to say about the y values? They're decreasing, right? We're going from, say this is 7 to 0, or 10 to 0, or whatever it is, but we're going down in the scale, okay? So as the x values increase, the y values decrease. Do you think that the graph would be helpful to you? Yes, then you probably should draw it. At least have it for reference, so you can go back to it. Because we're going to go back to the sheet again. Okay, so we've got our input and we've got our output, and they're labeled. Now, what is our end goal for number 1? To determine what?
Whether it's a function or not.
If it's a function or not, and give me a reason why. Okay, who wants to start us off? Yes, sir. Yes. Okay, so which input specifically, though? 12. The input 12 has how many outputs? 2. What are they? 2,000 and 3,000. So the output, the input 12 has 2 outputs. So it's what? Not a function. Not a function. Okay? Is there any other way that you could describe it?
I put it's not a function because it doesn't make any sense if 12 goes for both 2,000 and 3,000.
Yeah, it doesn't make any sense for 12,000 to go both to 2,000 and 3,000. That doesn't make it a function, correct? Okay. What else could you say? Yes. You're chewing. Not a function because every input needs one output. Could we use x's and y's instead? Right? Okay, so there's multiple ways you could say it. What are some ways? Well, I'm going to give you some ways that I would not want to see. Okay, I think for this class, pretty much everyone was good with their explanations, but I just want to give you an example from another class that I had. It's not a function because there are 2 of them. 2 of what? What's wrong with having 2 of them, right? I would like to have 2 cookies. Nothing wrong with having 2 cookies. 2 of what? What makes it not a function? Okay? I'm going to tell you something I told you. Any questions about number 1 before we move on? Sorry. You good? Okay, number 2. What do you think? What do you think we should do with this? Draw dots? Where? Along the curve, right? Because we know that the graph does what? Connects the dots, right? Eric, is that what you were saying through your yawn? Yeah? Connect the dots. Yes, connect the dots. Very good. So all of these dots would be along the line, and even more so, right? It would be continuous dots. So we drew our dots. Now it has chicken pox. Now what do? If it's a function or not a function, based on input and output. But what? How? How do I do that?
By determining whether the x-axis has
Every one.
y.
Make sure that every x-axis has one y-axis. Every x input, or every x value has one y value. Okay, you see the difference? Because you're telling me, does this whole x-axis have one y-axis? I don't know what that means. Okay, so you're right on the money when you say we need to look at the x-axis first. So we're going to look at the x-axis first, and then we're going to look at that relationship to the y-axis, correct? Yes? All right, Keston, tell me if you think this is a function or not. They're all on different lines. What kind of lines? Vertical or horizontal lines? Vertical lines, because we're looking at the x-axis, right? We're looking to see where do these x points go to? How many points do they hit on every single, on the graph, right? So every single x point hits how many y points? One, so it's a function. Function, I'm going to say it just like Keston said it. Function because every x
value.
Very good. X-axis. Every x value, you're right. Every x value hits one y value on the graph. When in doubt, always give as much detail as you can. It's always going. So, my father stood for a very long time in front of the dolphin pool. What is happening to the time in this situation? Well, what's happening to time? It's still going forward. Okay, what's happening to his distance? Nothing. It's staying exactly the same. Okay, so as time is increasing, distance is doing what? Staying exactly the same, right? So it would be this graph right here to go with this situation. Okay, so this graph goes with this situation right there. Does that make sense? Why? Okay, all right, next one I want to look at is this one, where is it? Oh, we walked quickly towards the snack bar and sat down to have a snack. Okay, what's happening to time? Nope. Can time decrease? Time is always increasing. Okay, what's happening to the distance? Okay, we're increasing our distance. We're moving towards something. If I move towards Keston, what's happening to my distance between me and Keston? It's decreasing, right? If you walk towards something, your distance from that object or from that person or that place is decreasing. Yes. So if we're moving towards something quickly, what does quickly tell us? It tells you that you're going like this. It's telling you the rate of change, the slope of that line, right? Okay, so it's happening quickly, and then what happens? You sat down. What's happening to your distance then? It's leveling out. It's staying the same as what? From when you first sat down as time continues to move forward, right? Okay, so which one of the graphs tells us that? We walk towards the snack bar, bottom right, right? This one right here. Does that make sense? Those two go together. Nope, I want you to move. There you go. Okay, does that make sense? Okay, what about this one? This one right here. What does that tell me? Distance increases and then decreases. So which situation increases? This one, Nancy? Nancy first ran towards the slide and then ran away from it. If you're running towards something, your distance increases? It decreases. So which one does it actually go with? My sister ran away from the roller coaster and then came back when my parents called her. So distance is increasing first. She runs away, and then she runs towards her parents again. Okay, so distance increases, then distance decreases. Okay, does that make sense? Does that clarify, Jordan? Does that make more sense? Okay, always picture in your brain, if I were doing this, what would my graph look like? Okay?